Okay. All right. Hey, sorry about the late start and sorry about the no stream this morning. We've had a plumber at the house looking at our water intake and chaos and mayhem and all kinds of stuff. And then my computer was being silly, so I had to reboot. Blah, 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 blah. Excuses. I'm Rob, that developer dad. It is Wednesday, December the 11th. And we're solving, or in general, I'm building applications using Microsoft.NET and C Sharp. Specifically this week, I am tackling sort of cross-cutting concerns that I keep running into in building other applications that are, and I'm tackling the ones that are really starting to bug me in my day-to-day. Let's build components that we can glue together into features and so on and so forth. And I'm really focused this week on the internal framework for the system that I'm actually working to keep as generic and opt-inable as I possibly can. So Monday and Tuesday, I started working on this concept of filtering, which allows us to escape the old problem of, say, for instance, our data APIs. So let's take a look at user account, for instance. And if I come into iUser account access, we've got save user account async, we've got load user account async. Cool. Now, in a typical API scenario, you'll also have things like task, user account, resource, get account by ID, string. ID. And then you'll also have copy. Whoops. Copy, paste by name. And then the project manager says, hey, we really need to be able to look up get account by color of socks. Third cousin's nickname, and so on. And our APIs and our access components, the contracts for those start to explode, and they get wider and wider and wider. And then over time, we'll stop looking up our customers by their third cousin's nickname, and we realize that we really don't care about the color of their socks, but we've got code out there that relies on it, and it becomes an unmanageable pain in the neck, because every time we add to this in order to consume it, we also have to alter the way the consuming components behave. And then, of course, we have to plumb all the way out to the API to add endpoints for that stuff. And it's a bloody nightmare. So what I'd much rather do is have something like task, IEnumerable, user account lookup, and that's just a fictitious class, and say filter user accounts async. And then that friendly little guy would take in a filter of user account resource filter, not Fitler. I got to come up with a better word than filter, because I'm perpetually mistyping it to rhyme with that guy with the mustache who did all the bad things. So here we can stuff whatever attribute things or attribute lookups or property comparisons and so on We can stuff as many of those on here as we want, and we never have to change the way this component behaves or the consuming components interact with our access component. Now, I haven't implemented this stuff yet, so I'm just going to delete that for now. I just wanted to do that for example purposes. And I'm going to close user account access without saving because I don't actually care about keeping those changes. So what I've built is this filter mechanism, and I've stuffed it into that developerdad.ifx. It's not over in the SystemFramework repository yet, but I will be as soon as I'm done with this next piece. I'll be porting it over. So we've got what I've called a subname space called collection utilities, and that lets us build a filter of whatever arbitrary criteria exist on the object that we're filtering. So just as a demonstration, I've created down in the console app that I'm using for component testing at the moment, I've created this other tests thing. It's called filter tests. And I think I was showing some of this off yesterday. So what I'll do here is, just for purposes of demo and review, I'll drop breakpoints before we get into these. Save, run. And I'll pull the integrated console or the integrated terminal up here. So far we've seen that we can test the filter class. We'll start with the simple criteria where the SKU of our subscription templates equals this value. And I'm printing out the materialized filter after it's been generated and turned into a Lambda expression. And then I print out how many items in the collection to filter exist once they pass through this filter. And then we add a criteria, do it again, and we've added DM familiar free. Renewal period is less than 100. We still have filtered count of 1. Cool. And then I got into the contains operator and the contained in operator, and those guys are weirdos. So contains is when we want to see if one of our object's string properties contains some substring. And we'll step in here. And I'll pull this down. We'll step over all this stuff. And here's where we add that criteria. So the property name is subscription template name. Operator is operator kinds.contains. And the expected value is familiar. So I'm going to pop over these. We've applied the filter. We'll print the filter out. So x.name.contains, the word familiar, and we should have 1 or 2, probably 2. So we have 2. Fantastic. And then we can add another filter where the name contains the word free. And we're filtered down to 1. So that's pretty cool, and I'm going to pop into how I build out these filters in a minute. So we'll get rid of that. And test the contained in operator. This guy's a weirdo, because what we want to do is we want to make sure that the property that we're filtering, that the property's value is contained in an array or a list or an enumerable of expected values. This one caused me several hours of tinkering yesterday after my afternoon session. So we'll step in, test the contained in operator. So the allowed values in this case are 7, 30, or 365. And I want to find all of the subscription templates whose renewal period is contained in this allowed SKUs variable. And I only did one test on this. So we're going to add the criteria. We'll apply the filter. Right line filter.toString. And we have 1. Because in my subscription catalog, the free renewal period is 0 and the monthly renewal period is 30. And so there we go. Now, in yesterday's stream, I got a whole bunch of code where we were creating the expressions, the link expressions that get compiled into that Lambda expression that we can see here. For instance, on let me run up the filter tests, and I'm going to comment this one and this one. We'll come into multiple criteria. We see in here on multiple criteria where we're adding 1 and then applying it, and then we add another criteria and apply it. And I'm going to drop a breakpoint. We can just let it run and then we'll inspect the output in a second. So we'll run it. And it does its thing. And you can see here where there's 2 filter criteria. The filter for subscription template is SKU equals DM familiar free and renewal period less than 100. And then we see the materialized filter, which is the compiled Lambda expression. SKU equals blah, blah, blah. And also renewal period is less than 100. Yesterday, when I was working through this stuff, inside build expression tree, we had all kinds of ifs and select cases and all kinds of goop. We can stop the execution here and shrink that down. And we'll pop that out here so that we don't have to look at it. So our filter clauses is a new list of expressions which live in system.link.expressions namespace. Our filter clauses, we just populate those. I created this as expression for extension method, or not an extension method, but method on the filter criteria class. And the filter criteria class got a little more sophisticated after hours as well. So in addition to just the property name, type, operator, and expected value, that property type gets assigned in the constructor, I believe. Or no, it gets assigned by the filter class when we call add criteria. So as expression for, what this does is it takes the information in these properties and turns it into a link expression. So we create the member expression, the constant expression, the expression body, and so on. I ran into issues during the last stream or the last video where when I was trying to build the final expression, the final query, it was getting angry because I was defining a different parameter or a parameter expression for the thing that we're searching over. I was building that in here and using a different instance of that parameter expression out in the main builder. And Link gets very grouchy about that. When we're building these expression trees, we have to use the same instance of this parameter expression object for the big master query that we're building, as well as when we're building each of the internal details of that query. And then the constant expression, I need to come down here because for is contained in actually operates on different types. So all of the other operators, except for that is contained in, require that the property type or the type of the property that we're querying has to match the type of this expected value, or at least be convertible. But when our expected value is an array or a list or a collection of some sort of whatever these property types are, then it gets grumpy. So instead of just being able to say constant expression constant equals expression.constant, and then the member expression and the expected value, we actually have to come down here and create this collection type of the expected value and pass that in as the type of our constant expression. It makes sense when you run it and step through the code and stuff like that. This will all be available in the SystemFramework repository, probably in a couple of days' time. So that's the first wrinkle. Now, as expression for, let's take a look at what's going on here. You goofball, what am I doing? Let's close this. Hey, C Films, how's it going, buddy? I am doing A-okay. So I want to go to the definition of this as expression for. And rather than having a big, ugly switch case that creates the materialized expression bodies for each of these filter criteria, I figured, you know what, it'd be much more elegant and flexible if I created an extension method for the operator kinds enum. So let's take a look at this. So this method is expecting some value of operator kinds, op kind. In order to build the expression body, we also need the member, the property of whatever it is we're querying, and the expected value in this constant expression. And then instead of just having simple return expression bodies, those statements still exist, but I've got them buried in actual definitions for each operator. I created classes for each of these operator kinds. And they're fairly tiny and fairly small, but what that does is it gives me a lot of flexibility in how those expressions get built. And so I created an operator factory, get operator. We'll take a look at that next. And here's a switch case, and all it is it's just a pattern matching type thing. So we pass in the value for operator kind, and then based on that, we instantiate a new materialized operator. So we'll start off with the simple ones, equal. And it inherits from operator base. Operator base has a handful of things on it that make our lives easier and more consistent. The operator base has a protected property that holds the kind of operator that it materializes. Our base class constructor, very simple, it just assigns whatever's coming in. We've got an abstract as expression that accepts the member and the constant. We've got an array of .NET types that represents which types this operator can work with. Because contains doesn't work for integers. And similarly, greater than and less than doesn't make a whole lot of sense for things like collections or strings, but it makes all kinds of sense for numeric or date types. And then, of course, there's this public virtual bool requires collection, which for all but one of these is defaulted to false. We override that down at the is contained in operator. Here's the list of available operators and their implementations. You know, typical equals, greater than, less than, greater or equals, lesser equals, not equals is at the bottom, contains, and of course is contained in. The project's going well. Actual feature work is slow because I'm solving things that I have discovered I am typing over and over and over again. I do not use any code review tools at this point in time, CFilms. I typically just stick with the Roslyn analyzers that are built into .NET itself for that kind of thing. If I were doing a lot of JavaScript, I'd probably bring in some sort of linting tool for that. I haven't really found any good C# linters that aren't a bigger pain in the neck to set up than just doing this manually. So as expression, this is unique to each operator kind. Let's look down here, and here we see that statement that we saw in the switch cases out in the build expression tree. We have, I just moved that expression.equal between member and constant down into the actual equal operator class. And of course, here's all our supported types, so on and so forth. Now, all of the numeric operators are plain vanilla, easy peasy. When we get into our two weird cases, contains and is contained by, well, contains, we have to constrain the types that are supported by it. Now, it's not very often that we're going to have a property of type IEnumerable, like a collection property, that we're saying this thing must exist in this list of this collection property. I've got it implemented here. I may remove it. If it gets too much of a pain to implement, then I'm going to zap it. But we can see here that all we're doing is just we're getting the a type value for the type of string. We're getting the contains method from string, and I'm using that null forgiving operator, that little exclamation point here, because I know for a fact that the .NET built-in string type has a contains method, and get method returns a nullable method info. But I know that string.contains is a thing. I use it all the time. We can take it for granted, so I don't feel so bad about using this null forgiving operator over here to tell the compiler to relax. And then we just return expression.call, and what this does is it turns member value dot contains, and then whatever value is in the constant. Turns object dot string property dot contains expected into a link expression fragment that can be combined with other expressions and compiled into a dynamically built predicate function at runtime. This next line turns that. Okay, good. So that's how contains works. Is contained by is the real weirdo, and it's the one that gave me some fits yesterday when I was working. Now, I'm just going to tidy this up here, because whenever I've got constructors that don't actually have any code in them, and the intention is that they don't receive code, I like to pull the braces up onto the declaration line. It's personal taste. Yeah, I haven't messed with either of those code review tools yet. As I said, the .NET compiler Roslyn does a pretty good job of pointing out when I'm doing something dumb. Save that. And here's our supported types, of course. We've got string, IEnumerables, and arrays. As expression gets crazy. Now, I've done a lot of refactoring because I had to do a lot of type checking and sort of pre-build validation. So rather than have that type checking and validation code right here inside the as expression method, I just factored those out to guard methods. And all the guard methods do is they check a condition, and if the condition exists, it throws an exception. And of course, this exception falls out to here, and I'm not doing any kind of try catch in here, so it throws all the way back to whatever called it. And I let the consuming code deal with that exception. Really, if somebody configures a filter like this, I want the app to crash. If I had another set of arms, another head, and another laptop, I'd actually build a Roslyn analyzer for all of this stuff so that when somebody, say, sets up this filter.egg criteria, it'll do all of that type checking automatically while you're working in the IDE and underline it with the red complain code. I may yet do that, but it's brand new. That kind of thing is a brand new concept to me. It's just plain old C# and .NET, but I've never done it before, and I'm really curious. I may yet build some analyzers into ThatDeveloperDad.ifx. But I don't need them right now, so I'm not going to do it right now. I do need this filter concept. And of course, we'll go back to operator base. We have to do the getContains method because there are different versions of this contains method for every kind of collection. So, in order to get that, we have to do some fancy footwork. All contains methods descend from IEnumerable.contains. And that just gets us sort of the non-generic or non-typed version of that contains method. So what we've got, base method now holds enumerable.contains IEnumerable object. All right. Now holds, actually it's an abstract, not typed version of collection T value, where T is some type that we aren't yet aware of. By calling make generic method on base method, we're getting the real contains function that we want to work with. Learn to type, Rob. For example, if element type is a string, let's say int, then our contains method will actually be that. Same concept holds true for other types, including custom complex types. And there we go. And if the contains method can't be built, out we go. We're going to barf all over the process. And that's the long and short of how these filter criteria get built into a link statement that gets run against any collection, as long as that collection is of the type that the filter criteria were built against. And we can see over in filter tests, we've got a filter of subscription template. We add criteria, name of subscription template dot stock keeping unit, operator, value, etc., etc. Let's take a look at add criteria real quick before we move on. So the first thing we have to do is we want to validate. We want to make sure that, well, first we want to get the property type. And inside this get property type or throw, because this method used to be a mile long as well until I broke it up into smaller, easier to digest fragments. So let's go to get property type or throw. It's right here. And what this does is, first thing it does is it interrogates, well, we get our subject properties. Let's see where that's assigned. So we're up in our filter constructor. The filter constructor accepts the type of the filter subject type. So here, filter of subscription item template filter equals a new filter of subscription item template. Let's run over here to filter and we'll take a look at the non-generic base class. Here's that. We'll look at the constructor on the generic filter class. So it's a filter of type T, where T is a class, filter, base type, type of T. So what this is it's using constructor chaining, and it's just passing whatever type corresponds to T into that base class constructor. Let's go back up there. So in here we've got the filter subject type. We assign that to a protected local variable, which means all child classes have access to that value. And then we're just going to use a method from the system.reflection namespace that gets an array of the properties that are declared on that type and holds that in a protected variable, so that all of the child classes of this filter, so all of the generic filter of T's that we're going to create, have access to this guy. And of course we create a placeholder for the filter criteria as we add them. So down here under add criteria, We get property type or throw. So in here, we make sure we just run a link query against that collection of type properties for the name that matches the property name that we're building the criteria against. And singular default means find me one property in this collection whose name matches this. If there's more than one, throw an exception. If there aren't any, just return null. And then, of course, if it turns out to be null, I throw, because we can't filter against a property that doesn't exist on the types. And then, of course, these other guard clauses, we make sure that the expected value and the type of the property are compatible with each other, that we can actually compare them to each other. And then, of course, we make sure that the property type and the selected operator are compatible with each other. And then finally, once all of those rules are passed, we create the new filter criteria object and add it to the collection. We reset that materialized filter and go ahead and build the filter out. And that's that. So I've demonstrated how this works over here in my test console. Pretty cool. I'm going to hide these guys. We don't need filter tests. We don't need operator base or any of this stuff. Let's take a look at our actual application code. And I'm going to come out to my managers. And I believe I am filtering a collection inside that CustomerBuilder. So here's build profile request. I don't need that. I need the CustomerBuilder. Here we are. And fetch and apply account information. Here's all this stuff. Create local profile. This is what we call internally if that account information comes back as null. So we do all this setup stuff. We do some validation. And I'm just going to go ahead and collapse these ifs. And of course, if our response has collected any errors at this point, we bail. There's no sense continuing because our object isn't in a state that is conducive to any further work that we need to do. So we add some external IDs if we don't already have one in our profile collection. And then we need our free subspec. So we know that we want the DM familiar free as our catalog item that we're going to build. Filter of subscription template free sub filter equals new. String free sub SKU equals, and I believe it's static. Oh, what's it called? Down here in my resource access catalog, let's look at the hard-coded crap. Static catalog provider. Oh, we don't have a reference to that. I'm going to copy these because these are values that we're going to need throughout the application, throughout this application. Subscription statuses, subscription renewal periods, new file, class, subscription identifiers. Save. Subscription identifiers dot that. Oh, I don't tend to worry about black space or white space at the end of code, at the end of a line of code. I do like to keep excuse me, I do like to keep things fairly compressed. Oh, blank spaces. Oh, like that. Yeah, I don't tend to worry about that. If I can't see it, it doesn't affect me. So subscription identifiers dot SKUs TDMF free. And I want to actually come over here and rename SKUs free. And I'm going to rename this to paid monthly. There we go. So come over here. That's a lot better. And free sub filter dot add filter. I believe it's criteria. Oh, what's it called? Add criteria. And I need the property name. So name of subscription template dot SKU. Property name is this. Expected value is that. Operator kind. Operator kinds. Dot equals. And I don't want to use that big long namespace chain. Save. Boom. Yeah, code file sizes, especially for things that have to get downloaded to the browser, really matter. Now, PHP is interpreted, not compiled. Is that correct? Although I think there are versions of PHP that do get compiled. Var filtered catalog. Yeah, okay. CatalogAccess dot filter catalog. And I don't think that's a method on there. It's not. That's okay. We'll add it. Catalog access. Oh yeah, there it is. But it's not accepting a string filter. It is expecting a filter of subscription template. And I need to rename that to filter catalog async. Save. Pop back out here, free sub, spec, get catalog item async. Drop to PHP, many other languages used for web applications. Yes. Yeah, many are. C# is not. C# gets compiled. Same thing with Java. I believe Go and Rust are also compiled. Honestly, when it comes to backend components, I really prefer I vastly prefer compiled services to scripted or interpreted services, but that's personal preference. So if filtered catalog dot any equals false, response dot add error, cannot load a subscription template with SKU free sub SKU. So could not finish creating the profile. Builder, create local profiler, subscription template not found. That works. Return response. And instead of filtered catalog.any, let's get var free template filtered catalog.first or default. Free template SKU. .sku, and then free template SKU. Is null or white space. Free template SKU equals true. There we go. All right. So now we got to come up here and actually implement filter catalog async. And here's get catalog. We've got that. Filter catalog. This isn't what we want to do. Here's get catalog item async. We're all good here. So we're going to put in async pop down, indent this, collection utilities, var filtered catalog equals filter.apply filter to the catalog. Now convert the catalog items into the filtered subscription items. Filtered dot add range filtered catalog dot select FC new filtered subscription item. And let's use IntelliSense. SKU equals FC dot SKU. Copilot, you're not that smart. Name equals FC dot name. None of that stuff's in there. It's just SKU name description. There we go. Test up from result, filtered dot as enumerable. I dig it. Save. Now, let's see if that works. I'm going to come down to program here. And I've got this other test, filter test, test filter classes. I'm done with those. So let's just comment that crap out. Save. I want to go back to my customer builder. We need a subscription template from which to build the initial default subscription that all users start with. Now we use that template to create a new subscription that gets added to the account profile. And I'm going to come up here and say file. Oh, there are no other things to save. So we're good. This is just validation stuff. And let's run it. See what we get. Bam. Okay, so it's doing all of our injection stuff, nothing more to do. It looks like it never got in here. Oh yeah, of course, because there's already a subscription item up there. Duh. Give me a second. I'll pull this over here. Go to the Azure portal. Sign in as me. And I'm going to delete the local profile for the for the test account that I'm working with here. So business objects, I am looking for Geek Dad. Here we are. Let's delete that. All right, we should get into this now. And then once we get here, I want to talk about some complications we're going to run into with using this filter concept that I have. Right here, it's kind of contrived, and I'm kind of like finding a problem to match the solution I've built. But I guarantee I'm going to want to use this filter capability elsewhere. I've already got applications for this capability, in the product application, and I will have applications for it elsewhere in this administrative portion, and in basically any other application I ever write that deals with collections that are stored in a database or some other resource storage place. So let's run it now. I've deleted the test account model from Azure Storage. And here we are. So we've got all this stuff. The free sub SKU is DM familiar free. We've got our filter. Free sub filter. Cool. And we're going to pass this subscription filter into CatalogAccess filter catalog async. Let's step in. Oh, we get to go through the proxy behavior. That's okay. Here's where we actually invoke the method, and in we come. So we're creating a new empty collection, because whenever we have a method that the return type is a collection, and we don't find anything to fill the collection, we always want to at least return the empty collection rather than null. And so filter.apply filter, our catalog. What's our filter look like? It has exactly one criteria, and we're looking for SKU equals DM familiar free from our catalog. It's got 2 items in it. So I'm gonna step over it. There's no need for that. Filtered catalog, we have 1 item. From every item in our filtered catalog collection, we're going to build a new filtered subscription item. Boop. So filtered has 1 item. The SKU is DM-familiar-free. Name is the DM's familiar free tier. Provides access to yeah. And we return a task.fromResult. Step out through our proxy stuff. That's something I should look up, is if there's an attribute I can add to that pass-through proxy that it should just ignore, or not step through, but step over all of that stuff. So our filtered catalog should have 1 item. Cool. Our free template SKU, filtered catalog.firstThroughDefault, and I just want the SKU. My free template SKU is DM familiar free. We're good. Let's fetch. Our free subspec is here with all of the resource grants that we want to add and all that stuff. And now we can just continue running. Now, to use this filter method, or this new filter method that we created, it actually used a lot more code than just catalog access, get catalog item async, pass the constant that represents the SKU, yeah. But we've given ourselves a flex point here, and I've been able to demonstrate how to use this filter concept in real life against an actual collection with an actual business case. And imagine if instead of a hard-coded catalog with 2 items in it, I had a gigantic catalog that was loaded from a database. This would be a whole lot more powerful. A whole lot more powerful. So this pattern's pretty nice. I like it. Now, the issue here is in type mapping. Let's say I had a filter item or this catalog filter concept described against a type that's local to my manager project. So instead of expecting a filter of type subscription template, it was expecting a type of subscription template resource. And the manager, when it's building filters, would be building filters against subscription template. So those are 2 different types, and we're going to start to run into trouble there. So what we would need to do is either build a brand new filter against subscription template resource from scratch, or come up with some way of decorating the resource class against the manager class, which are really just 2 different expressions of the same concept, with some attributes that describe that each of those 2 classes are just different views of the same business concept. I'm going to start laying down the infrastructure to implement that concept after the stream, like for the rest of the afternoon. And we're going to dig into, we're going to review what I do and apply it, or start applying it throughout this application, probably with tomorrow's morning stream. I am at time. I've got other things that I need to do. I want to start digging into the code aspects of that, of this type mapping. Hint, we're going to make heavy use of .NET attributes. So just to give you a preview of where we're going with this idea, excuse me, let's take a look at a subscription item template, just for laughs. So we've got our plain .NET classes here. We don't need to worry about the constructor or anything like that. And it's got properties and descriptions and all that stuff, right? And these exist as completely independent representations of some domain concept. And I just put together a slide deck about this very thing earlier this morning. So we get into this concept from domain-driven design called ubiquitous language, where within a business, we've got all of these different processes and all these different departments and so on that operate on the thing. And where a lot of domain-driven design things fall apart is they'll come up with one great big giant definition for the thing that has every bit of information about the thing that could ever be required. And that big giant God object is shared between the customer service software and the finance software and the shipping and fulfillment and the analytics and all of the different departments in your company. And all of the programmers that are working on the software for those departments have to deal with that one big god-awful thing, when in fact they really only need a subset of the properties around that canonical object that is the thing. So we get into sort of idiomatic expressions of. So we'll have a customer service thing, a finance thing, a fulfillment thing, and those are limited views or subsets of properties on the thing. But that gives us a lot of mapping. And if you've been following me for any amount of time and watched a few of my videos, you will see that I have done all kinds of mapping code, like scads of it, hundreds of lines of code in this solution already. And I'm just getting started, are dedicated to translating between the manager's view of what a customer profile looks like and the resource access view of what that customer profile looks like. And right now, even though they look very, very similar, over time, I expect those views to diverge. And that's why I'm not using the same class in storage and resource access and any computation engine components I might build, and certainly not on the publicly consumable API for the DM Familiar admin system. So I'm going to write a ton of this mapping code, even though each of these objects represent the same conceptual thing, the customer profile. I want a better way of doing that. So just by way of example on this customer subscription on this subscription template, what if I domain entity equals subscription template? And I got to spell template right. So domain entity subscription template. I can't remember the exact syntax for using attributes. And domain entity isn't a known attribute. I'm not worried about that. And then, of course, domain property, entity name, subscription template, attribute name, template ID. And of course, I typed that wrong, but you get the idea. And then we would define these domain properties throughout for each representation of this subscription template on the different classes. And then I come out to IFX. And I would probably define these domain entities like these strings. I'm likely going to create classes, not real classes, but classes for each domain entity out here in the SysAdmin IFX. And all they're going to do is hold constants. That's it. Constants that represent these strings. And it'll make setting up these attributes on my actual material classes much, much easier. And then in that DeveloperDad IFX, I've got collection utilities, new file, new folder. Let's say domain utilities. And I'm going to call it the class domain object mapper. And I'm not even going to add anything to this yet. But the domain object mapper provides methods by which we can more easily and consistently map between idiomatic expressions of canonical domain objects between different idiomatic expressions of canonical domain objects are declared in our systems. And we're going to dive into that in greater detail tomorrow. I'm going to get rid of these BS attributes. But the big advantage of this is these object mappers over here in utilities, I'm going to be declaring the attributes and the methods that use those attributes on decorated classes, but we're not going to have any actual knowledge of the domain itself inside our framework. And the mapping code is going to move from living in, or the mechanic of mapping an object of one type to an object of another type is going to move from living in here in our application code or our component code. We're going to centralize and standardize that into a utility. And we're going to start building that code, or we're going to start talking about that code and that concept in greater detail in my next session. And now I really, really got to go. I really, really mean it. Thanks for hanging out. If you have questions or what have you, and you're watching this on YouTube, please just add comments, like, follow, subscribe. If you're watching me live on Twitch, follow me. Once I get affiliate, you'll be able to subscribe, but I'm not an affiliate yet. Still working on that. And yeah, I'll see you all next time. Be kind to yourselves. Be kind to the people around you. And remember, coding can be fun. So happy coding.